bottom.
Oh, good.
Yeah.
It's cold here.
We'll put it live, and you have to see if you have it.
And I understand for is Steve going to be doing slides, Karen, this morning, or is he just talking during his? He is doing slides. Okay.
Yes.
And then he sent me a note that for the panel, Nicholas is not doing slides, but everybody else is doing slides.
Should we go through them?
Correct.
Sorry?
You want to see them, the slides? I can.
Sure. The only part I didn't know on was if there were seed questions for the panel, because I didn't have questions for them already, so I wasn't sure if there had been anything developed or if I just need to take copious notes during the panel and then come up with my own questions.
Okay, we start with this.
Steve's pretty good at asking those, but I think what we need to figure out is why you weren't seeing those. And if you have the mobile app open, you should see the questions.
I actually saw them on when I click on the session for the
Yeah.
panel, even though I was able to pause the video, the questions were still coming in the chat or the
Good.
question.
Okay.
But if you don't mind, Karen,
Okay.
just as a fail-safe to feed it through WhatsApp as well, that's kind of a good feedback.
Question, do you hear the video sound?
No,
No.
I just see the video, but I don't hear the audio.
That's good. It's
Okay.
it's on, so we will not hear any audio from the PowerPoint because of delays and all that, but it will be on the stream, so don't panic.
Okay. I try to avoid
Okay.
panic at all costs.
Okay, when you see, so after the movie, we have something like this, then we go like this, then it's up to you.
Yep.
The introduction for today, welcome to day 2. Afterwards, we go the introduction to Steve.
Mm-hmm.
And then we start with Steve, all his slides.
Right. And then I come back on,
Yeah.
and I introduce the panel.
Yeah.
And then the sequence of speakers as I have is Katrine will speak first, Nicholas will speak second, and John will speak third.
No,
Followed by
Right.
Q&A.
Nicholas has no slides.
Correct.
Correct.
Okay, sorry. Yeah, okay. Then
So
we start with
Katrine.
I give
Katrine
her
and
rights talk. It's this one. Then we're back. Are you gonna introduce the next speaker here, or are we?
I will, sure. I'll introduce all of them, and then I'll kick it off and say we'll start with Katrine, and then Nicholas is going to speak, and then John will speak third, and then after that we'll do questions.
Okay, and then we go. What's this? Okay, then we go to the third one, without any name. Fourth. It's John. Okay.
John Schmatzer. Yeah. Whew.
So we have this. Oops. And that's it.
That's it, and then Q&A, and then we'll break at 1600.
I don't have a Q&A slide. Karen, is it?
I'm sorry. I thought it was in there. I forgot it.
I just add one here,
Sure.
and then we have the last slide, and then the movies.
Yeah.
So on the videos, Karen, I just want to, when I do we'll go to break, I'm going to say we're going to be seeing some videos from Itemus and Geotab. Is that accurate?
Geotab. Yeah.
Geotab, and yeah, Itemus
Mhm.
first and Geotab second.
Right.
And then, do you want me to just do a little preview and say, and we'll be coming back at 16:15 with our first afternoon workshop on common vehicle interface, and then.
Well, we won't be coming back. That's the thing. So it's not being streamed. It's
oh,
Zoom.
that's right.
So if you look at can you back up a couple screens there, Tom, where I have that text?
Sorry?
Back up that screen where
Welcome to day 2 of the 2020 Geneva All-Member Meeting, an interactive online conference. My name is Chris Barker. I'm the president for CBC, a global transportation and smart city consulting firm. This is our second Geneva online event this year, and we want to welcome all of you joining us from around the world. I'd like to provide a brief overview of what's happening on day 2. First, I'd like to thank our sponsors, executive sponsor Genesis and gold sponsor LG Electronics. Their support of the Alliance is greatly appreciated, and we suggest you take time to view the new product videos and connect with their team members this week. The ever-popular Geneva Demo Showcase is open through Wednesday of this week. As you visit our exhibitors in the Demo Showcase, you'll have the opportunity to book one-on-one meetings, view their videos, and download product information. This is a great opportunity to network on your time. You will also notice that our event is both live and pre-recorded. You can register for the sessions in advance and will receive notification via the Geneva mobile app when sessions go live. This will allow you to use your time efficiently so you don't miss any of the critical sessions or important Q&As. It is my pleasure to now introduce our first speaker, Geneva Executive Director Steve Crum, who will provide an overview of today's event, highlighting Geneva and the W3C overview, and the Common Vehicle Interface Initiative. Good morning and welcome, Steve.
Well, good morning, everyone, and thank you so much for joining today. I wish we could be together, I truly do, but we all have circumstances beyond our control, and so we'll make the best of this virtual experience, and hopefully it will be meaningful to you today. On behalf of the World Wide Web Consortium and Geneva Alliance, I'd like to welcome you to today's activities, and I just want to give a brief overview, as Chris said, to some of the things that we're thinking about as we launch this Common Vehicle Interface Initiative. While I'm sure most of you are already familiar with W3C and the Geneva Alliance, just give me a few seconds to remind you of the organization's respective missions and activities. The World Wide Web Consortium, or W3C, is an international community that develops open standards to ensure the long-term growth of the web. Those open standards have fundamentally changed the way people interact and how businesses operate today. We are pleased to have the W3C CEO, Jeff Jaffrey, join us during the first workshop to give us a little bit more understanding of where the web standards are headed and the impact that they intend to have in the future. So we'll look forward to that and welcome you to join that. The Geneva Alliance had its beginnings in developing a Linux-based open source platform for in-vehicle infotainment systems. Having successfully accomplished that initial mission, Geneva has expanded its scope to help automakers and suppliers develop standard approaches that integrate multiple operating systems in the centralized and connected vehicle cockpit. We are also enhancing vehicle connectivity to the cloud and promoting a common vehicle data model and shared service catalog. So with those introductions, let me talk a little bit about, tell a brief story about two vibrant industries, and you can probably guess what those vibrant industries are. But unfortunately, they were separated for a very long time. For many years, these industries provided great benefit to their respective consumers. The web industry connected people and businesses as never before. New models of doing business were derived from this new connectivity. And at the same time, in the automotive space, new and compelling features were brought into the car. Driver assistance and new safety features were introduced. And drivers and passengers began enjoying seamless integration of their mobile phones into the vehicle experience. Both industries were making and continue to make a very positive impact to their consumer base. But the two industries, unfortunately, were separated and were not used to conversing with each other. And like this drawbridge on this picture, it kept them from meaningful exchange. They could see each other and they could even taste the potential benefit of engaging with each other, but the bridge just simply did not allow it. But then the idea of working together came on the scene, perhaps radically at first and without much caution, but the leap was made. And for the first time, the two industries began to discuss the potential of working together to bring their respective industries and technology leaders together. W3C and Geneva Alliance created a framework which productive exchange could occur between these two industries. And having bridged the gap, dialogue began, and the two industries engaged with each other to find approaches that could mutually benefit their respective consumer base. Within a small amount of time, the collaboration produced two standards, both of which are gaining adoption and forming the basis for more advanced interactions between the vehicle and the web. As you can see on this slide, the Geneva Vehicle Service Specification, or VSS, has become a candidate, an industry-wide candidate, for a common model for vehicle data. Extended by version 2, it's freely available on the Geneva GitHub repository for download. It's being deployed in production vehicles, and it's poised for expansion to include services and interfaces. And finally, it is a firm foundation upon which this common vehicle interface initiative that we'll discuss today can be based. In the web side, you have the W3C Vehicle Interface Service Specification, or VISS. That describes associated protocols and interface technologies to make use of the data and service model of VSS. Released already as a W3C candidate recommendation, it also is being extended into version 2 and is poised for expansion to include function calls, RPC-like mechanisms, and also forms a second strong foundation for this common vehicle interface initiative. So building on those two foundations, a new and even bolder vision is being cast to engage the two industries in an initiative to develop a common vehicle interface. This vision is very bold because it spans both in-vehicle and in-cloud approaches. Sorry, went one too far there. It's a bold vision for a number of reasons. It's bold because it spans in-vehicle functions and in-cloud functions. It cares about the data as well as the function and services being exchanged between the cloud and the vehicle. It aligns with and leverages other standards being produced in many different contexts, some of which are listed here. And it also puts the vehicle in many other broader ecosystems like the Internet of Things, the Web of Things, V2X, smart mobility, smart cities, etc. And it has the potential for unlocking significant cost savings for future programs, vehicle programs, as well as many, many business opportunities, not just for automotive stakeholders, but also for web stakeholders as well. So starting today, we're going to begin this conversation about CVII. We've already had two roundtable discussions with several OEMs describing at a high level what this initiative could look like. And several have already expressed support. And today we have the opportunity just in a few minutes to hear from Ford, Renault, and Volvo Cars to talk about why they believe the industry needs this initiative. But it's now time for both organizations, both industries to step up in this industry-wide dialogue initiated by W3C and Geneva in what we're calling the Common Vehicle Interface Initiative. It's an obvious leap. And after the panel, we'll have two workshops co-moderated by W3C and Geneva, and then a follow-up workshop on Thursday to engage an Asia-based audience that may find today's time challenging to attend. And so you can see on this slide the various schedule ahead of us today. So when we started this presentation, we talked about two vibrant industries being separated by a drawbridge. Geneva and W3C have experienced in the past few years a productive collaboration between web and automotive industries, resulting in two foundational and evolving standards to build upon. And today, we are proposing an even broader vision to evolve the relationship between the car and the web to a totally new level. The purpose of today's panel and the workshops today and on Thursday is to answer some very hard questions, like what are the boundaries of the scope of this initiative? What are the expected concrete deliverables of this initiative? We need to explore the need for existing organizations already working in the vehicle data area to work together and to share their respective approaches. And frankly, we have to answer the question whether a bold initiative like CVII is even viable in our industries today. We believe it is. And we want to start today to explore that. So locking arms may be cliche, but productive collaboration, not just between W3C and Geneva, but between OEMs and suppliers, web development companies, standards bodies, has great potential. And we would like to begin to realize that potential starting today. So I close with a question and with a challenge. The question is there a World Wide Web-like impact awaiting the web and automotive industries through productive collaboration and alignment resulting from a successful common vehicle interface initiative? It's a great question, and I hope it's one that we can answer today and in subsequent meetings as we walk away from this event. But let's start to begin to answer this question today. And the challenge? Let's find out. So with that, if there are any questions about Geneva, about W3C, please jot down the names and addresses here on this slide. We welcome additional participation and commitment and membership as well. We're both membership-driven organizations, so if there's anything that either organization, W3C or Geneva, can do for your organization to help build a productive collaboration in this area, please let us know. So with that, I'll pass it back to Chris, and I wish you all a great day talking about this new initiative. Thank you.
Thanks, Steve. And we are now going to kick off our first panel session this morning, focused, as Steve mentioned, on why the industry needs a common vehicle interface initiative. And it's my pleasure to introduce our panel of speakers this morning. We have Katrine Mathis from Renault Software Factory, Nicholas Yillerman from Volvo Cars, and John Schmatzer from Ford Motor Company. And I'd like to kick it off with Katrine, who's going to give some thoughts to this Common Vehicle Interface Initiative. Katrine, welcome.
Yeah, hello, thank you. I'm Katrine Mathis from Renault, and I'm very pleased to be with you here on the panel today. If we move to the first slide. So sorry, I still see the introductory slide. Yeah, thank you. What I would like to introduce, maybe if we can go to the next slide, are already some high-level consideration and type of application to be considered for CVII. We have today in the car different types of application. So we have application running potentially on an AUTOSAR classic type of platform, which are not connected, but which provide interfaces and data to application that may run on a more high-level OS platform, like we find in the infotainment, but also in the connectivity. And here we have a hybrid application, which are both running onboard and offboard. So typically navigation and virtual personal assistant are today part of this application. And then there are also applications that are running purely offboard in either OEM or public or other type of cloud, and which also require some form of access to the vehicle side of data and interfaces. Some of the challenges is that requirements of this application may be very different. So we have cybersecurity constraint, functional safety constraint, partitioning constraint. And so we need to take this into account when talking about common formats and interfaces. These applications need access to onboard resources, but not necessarily to the same type of resources. So some need access to sensors, others already pre-processed data, some need access to HMI interfaces. And so this is also part of the challenges to find common denominator for formats and interfaces. But yet we see an opportunity to specify data formats and also look at where common data sets are used, where are common denominators between different types of application and services, where we can first focus on to specify these data formats. If you go next. So we can also look at already existing ecosystem and what made these ecosystems successful. And in these ecosystem, we find obviously Google Automotive Services, which have largely been derived from the Google Android platform that is running on smartphones, but also TVs and other type of environments. And then there are smartphone replication platforms like Android Auto and Apple CarPlay. And what made these platforms widely successful is that they had commonly specified interfaces, so the APIs, and also software development kits, which enabled a large community of application developers to provide applications and services on this type of platform. And so when we think about standardizing vehicle data format and interfaces, we need to consider this existing context. But also, as Steve mentioned, there are many other ecosystems, including smart city, mobility, among others, that are not currently addressed by these ecosystem on the application and infotainment side. And so there are large opportunities to extend existing APIs and the associated data and provide really a common basis for these various applications in these different ecosystems. And when looking also what's happening currently in the automotive industry, there is a clear trend to move away from signal-oriented communication, which is still largely deployed in the vehicles, where we have ECUs talking with each other on signal base. But the expansion of the number of ECUs and also the software in the car makes this largely complex to address. And so there is a trend in the automotive industry and in cars to go towards service-oriented architecture. And if I take a citation from Werner Vogels, who is still CTO and VP at Amazon. So this is quite old statement he made in 2006, before Amazon became the giant it is today. He said that service orientation means encapsulating data with a business logic that operates on the data with the only access through a published service interface. And this is in essence also the challenge we have, defining services and the associated service interfaces. And so we have the interfaces mainly in application layer that build on a common set of services. And then the challenge to specify the underlying data formats which come out of the different vehicle functions.
You're on mute, Chris, I think.
Thank you. I'd like to now introduce our second speaker, Nicholas Ilram from Volvo Cars, who's going to share some thoughts as well on CVII. Nicholas, welcome.
Thank you. And thank you very much for letting me be part of this meeting. I would like to start by briefly introducing myself, just to give you some short background. My name is Nicholas Gyllenram, and I've worked with software development in the automotive industry my whole life, almost, for too long. I've currently work for Volvo Cars. I worked for Volvo Cars for the last 5 years, and for the last 2 years, I've been based in California, where we have a tech center in Sunnyvale, and I'm leading the R&D teams there. I previously worked with software development, building infotainment head units for Mitsubishi Electric, and I was actually part of Geneva in the early days, more than 10 years ago, representing Mitsubishi Electric and this was back when the focus for Geneva, like Steve alluded to earlier, was to build a common open source infotainment platform. In 2011, I worked at Ericsson with cloud development, and we were actually developing a cloud solution for Volvo cars. And after another brief stint at Mitsubishi Electric, I joined Volvo in 2015 to start building up Volvo's in-car app development. And then in 2017, I was made head of strategy and concept at Volvo, and that's when I started our partnership and collaboration with Google to build an infotainment system based on Android. Now, the reason I went through that whole background was that the very reasons why we started our Android development at Volvo were the same reasons we joined and worked with Geneva from the very beginning. We want to be able to share commodity code. We want to have a sensible ecosystem for suppliers to build great software and great experiences on. And we want to be able to focus Volvo's resources only on what nobody else does better. 1 cent spent on something someone else does better is a wasted cent, pretty much. In the realm of infotainment, we finally start to see some commoditization as Android is becoming one of the larger or potentially even the largest operating system. And that is, of course, good in the sense that it means we no longer need to reinvent the wheel and build Volvo unique or OEM unique navigation systems or speech systems that other can build better. However, at the same time, the infotainment system is gradually becoming less important, actually. The software we have in the head unit, it used to contain roughly 98% of all the software in the vehicle, just counting lines of code. In the last couple of years, with developments in active safety systems and down the line autonomous driving systems, this has started to shift, and we also increasingly see how cars can become nodes in a true Internet of Things, where cloud development becomes increasingly important and significant. So this means that the weight of development in terms of software is shifting not only away from infotainment, but away from the vehicle even. And outside of infotainment, we are pretty much back to where we were with infotainment 10 years ago. There is not really any sensible way of sharing code or data models between different OEMs or different industries, or even between car models within an OEM. There's not even any sensible way of sharing data from or to vehicles. We have fragmentation not only between how different OEMs handle the communication within the vehicles or between vehicles and cloud, but even between different car models within the same brand. We at Volvo will see that different models we produce not necessarily speak the same language. Obviously, this is an industry that has become prohibitively difficult to engage with. Not only are our cars internally speaking different languages, our clouds are speaking different languages. And to tell the truth, I don't think anyone understands one iota of what we're saying. This all boils down to an incredible, immense waste of resources where Volvo and other OEMs are spending, or I should say we're wasting our money building platforms, defining unique interfaces, and constantly reinventing slightly less than round wheels to the benefit of no one. We can do better, and frankly, we must do better. And to me, this is the driving reason behind why it's so important to try to find a common interface specification and common data models that extends outside of the vehicle as well. It's the only way that our cars can connect with each other or with other devices or with infrastructure and provide really meaningful benefits to society. I think this is certainly one of the top priorities for Volvo and for the automotive industry as a whole. Having been part of Geneva from the very beginning, I would like to caution, though, that I think it's completely essential that we take the step from not only sharing specifications, but to actually sharing code and implementations to actually succeed. Cars are in themselves complicated systems, and cars connected to other cars, their infrastructure, are even more complicated. It's obvious that to succeed in this arena, you need to collaborate. That is what Geneva and W3C is all about, and that's why it's so important to Volvo. And that's why Volvo are re-engaging in Geneva, why we've been engaged with W3C for a long time, and why the collaboration around data models and interface specifications will be essential to all of us. And bottom line, that's why I was very interested to join this panel, and why I hope to be able to provide you with some things that you might find useful. And to go back to the question you asked, Steve, is there, what was it? Is there a World Wide Web-like impact awaiting? I think that's completely certain. I see no way that it could not be that kind of impact awaiting. We just need to find a sensible way of working with each other here. Thank you.
Thank you, Nicholas. I'd now like to introduce John Schmatzer from the Ford Motor Company to share some thoughts on CVII. Welcome, John.
Chris, thank you so much for having me. It's been a pleasure to be able to sit on the panel with Nicholas and Katrine, and especially a warm thank you to our partners in Geneva and W3C for welcoming me as a little bit of a new member into the fold. So a little bit of background on myself, just very briefly. I'm about 6 years in at Ford Motor Company. I am our connected vehicle data integration manager within Ford. And prior to that, I spent about 5 years in the defense industry, working on similar systems that we're seeing introduced into the field today in the automotive space. So very much a passion space for me. So you've heard, I think, very eloquently from the other panel members around two of what I would propose are the three legs of the stool: SDKs, APIs, and interfaces. The cloud ecosystem to be standardized. And what I want to just briefly highlight on is the third, what I believe is the third leg of the stool, which is the in-vehicle data that enables the ecosystem to thrive. So just very briefly, we'll jump in. So automotive has been talking about a litany of industry trends, from autonomy to electrification to connectivity to domain consolidation. But at the bottom of that sort of pillar is this foundational piece of vehicle data. And you've heard the consultants talk. They're talking about a very large business opportunity from McKinsey and BCG and the other firms around establishing a standardized technology stack within the ecosystem. But again, at the bottom of that foundational platform is the vehicle itself, which, for those in the industry know, is its own has its own level of complexity involved in making it a fully functioning unit. And so going into trying to hit some of those industry trends with the next S-curve of innovation towards autonomy, towards battery electric vehicles, et cetera, what it's doing is it's creating what were used to be differentiating features and components in the vehicle, and in effect turning them into commodities. And by proxy, data that was once specifically designed to create a differentiating experience within the vehicle, does that become a commodity too? And by proxy, is that value opportunity changed? So if you look at the underlying data model for a vehicle, there's upwards of 10,000 and more unique data elements in any given vehicle that we have to standardize, curate, and expose for a variety of connected vehicle purposes. And so when you look at it from that high-level philosophical standpoint, it looks great. You're like, hey, all right, I can do this. This is all curatable. It's exposable. But when you actually roll up your sleeves and you go one level deeper into the ecosystem, you kind of look around and you say, hey, there's a little bit of a mess down here. How do I start to standardize and encapsulate this into something that's consumable for someone that doesn't live it on a day-to-day basis? And so I think Nicholas and Katrine highlighted, the need to be able to scale out functionality and capability to a software development community. Well, in order to do that, they need to have some level of a level playing field to stabilize on. And the industry is just really not quite there yet as a whole. And that's where, at least for me, I see an intrinsic value in what W3C and Geneva are proposing from an open source standard with the ability to code share, et cetera. But I do want to take it and challenge the community to take it one step further. What does that industry standard for the embedded ecosystem for the vehicle look like? What is the relationship between an analog brake controller and a powertrain controller that we could standardize in a way that offers a reduction in engineering expenses, a clear linkage to our connected vehicle space, and establish those common interfaces, not just on the cloud ecosystem, but driving all the way down into the individual vehicle module ecosystem, so that the engineering effort required to expose the services through SDKs and APIs is fundamentally reduced across the ecosystem. And so, just to highlight some thought processes, some experience that I've been exposed to in a previous life. This is not something that's new. There are other industries that are already doing this successfully. A beautiful example is the Canon automation industry standard, which provides this construct, which I like and copy with pride, of device profiles with clear delineated data models on a per function basis. So this is something where we don't need to go and directly copy the approach, but certainly we can take and borrow the best in class of these other industry standards and start to model them in the automotive space. And so Ford took that initiative. We developed our own sort of software library for the embedded module, and that is in production today. But that's not a scalable solution for Ford to do that by themselves. That's something that provides a one-off. It creates challenges for our tier 1 partners, because now they have to create a one-off solution for Ford, where what they would rather do is create a common interface across multiple OEMs. And so the timing, and part of the reason I was so excited to join Nicholas and Katrine on this panel, is that we are seeing a interest in the automotive industry to consolidate the modules within the vehicle into what we're calling domain controllers. And so the patient is starting to open up. We are reevaluating how we're approaching the technological capabilities of how we design vehicles. And so with that, we are going to have to refactor the code bases that enable our vehicles to thrive. And so from a timing perspective, is not now the best time to have a conversation around not just what the cloud ecosystem should look like, but what the in-vehicle data model should look like at a comprehensive level to, as Nicholas said so eloquently, drive down unnecessary engineering expenses and create a clear open standard. So there's a variety of additional slides that I have here that I'm not going to go through at this moment to leave time for the Q&A and the dialogue. But I do believe Geneva has set up a number of workshops throughout the week, and I would encourage folks to join and provide their opinions and their thoughts on how we might do this collaboratively, because Ford's not really waiting around at this point. So with that, I'll turn it over back to you, Chris. Thank you so much.
Thanks, John. We're now going to move into our Q&A session, and I want to invite folks in the audience, if you have questions, feel free to pose those in the questions tab on the event platform, and we'll happily get as many of those covered as we can during this time. In the meantime, just a couple questions to kick things off. So you've all talked about us being at this transformative period in the automotive industry, and now the integration between vehicles and their broader environment within cities, within how they function. How would you describe kind of where we are and what we can expect moving forward in the next, say, year to 2 years as the vehicle becomes more of the node and it connects with smart city technology, smart city infrastructure, and becomes more than a standalone vehicle, but it becomes more of a connective element to the broader ecosystem that these vehicles are operating in? And I'd be just curious for each of you on the panel, if you could kind of just share your thoughts of where you think we are today and where you think we're going to progress, say in the next 12, 24, or 36 months. And maybe, Katrine, I'll start with you if you want to share your thoughts on that.
Okay, so I think today to move more quickly in these kind of ecosystem, and I think we mentioned it, we're lacking the common specification and interfaces, and so there are different initiatives that are already deployed in different services. But I believe that currently it's quite heterogeneous, the way it's deployed, and even in context of smart city, the deployment is a bit slowed down, because currently we can look at the vehicles as IoT devices that have all sort of their own way of functioning, and it's difficult for even smart city to build common application. So the standardization works for some areas like charging electric vehicles, but beyond that, I believe that the services are yet to grow, and we need to find a common foundation to help them grow.
Very good. Nicholas or John, your thoughts?
Yeah, I, of course, agree with Katrine. Most cars over the last decade have we've been starting to build connected cars, but they're not really connected to much of anything, apart from, in best case, some OEM unique specific cloud implementation. They're hardly ever connected to other vehicles. They're definitely not connected to other OEMs. And then you have all these one-off implementations where we do specific integration, like John said, how it can be currently when you within the vehicle. That's how it is outside of the vehicle as well, where sometimes someone will integrate with some service provider or some data consumer or some city to have some kind of part of a smart city integration. I expect that over the coming 12 to 24 months, you will gradually start to see some initiatives happen here. I expect that fully. I expect this initiative to be one of the driving factors there. And that is where I see this explosion, like World Wide Web like impact, when we actually start to share data outside of the vehicles, both mainly from the vehicles, but even to the vehicles, from other cars and from other industries, from infrastructure in terms of traffic light systems and traffic control systems or emergency services and so on.
Very good. John, your thoughts?
I think it's hard to follow Nicholas and Katrine. They've laid it out pretty accurately. We've seen some fits and starts in the space. I would say Ford has been part of that fits and starts experience in the last couple of years, based on what we've publicly announced and what we're trying to do in the ecosystem. The future is not concrete. It takes a village in order to create these types of ecosystems. You know, the opportunity is going to be finding the right couple of partners to create those standards, and then more importantly, to execute them and show the value. And then once that's done, then the rest of the ecosystem will start to come together, and that growth, that sort of exponential growth will happen. So for me, I got to start my career in an ecosystem that was already standardized. And so by proxy, I was able to learn the efficiency that was gleaned. And so while, you know, I do recognize, you know, all how should we call it, the long journey in front of us. I've seen the end of the light at the end of the tunnel, and it's a pretty beautiful light. And you can do some really cool things for the customer at the end of the day. And then that's what we're here for, right? At the end of the day is we want to create this experience where the customer wants to come back and enjoy the product again and again and again. And I think this is a mechanism that will enable that more effectively in the future.
John, I'm glad you brought that up, because you mentioned your work previously in the defense industry. And yesterday, Matt Jones talked a little bit about kind of what's happened on the defense side of the world that's worked into the commercial markets. And you described seeing the light of what the future holds. Any thoughts on how one industry like defense has influence or can help advance things in the commercial market when we're talking about things like data sharing and common vehicle interface? Any insights from your past that's helping guide you in your present and your future?
Sure. There's only so much I can go into. So some of it's still classified.
Right. Sure.
Maybe one thing off the top of my head. A big movement back in the 2009 timeframe in defense was the abbreviation called COTS, and it's COTS, and it's commercial off-the-shelf technology. It was the abbreviation. And so there was a big movement to leverage capabilities that were already in existence to integrate sophisticated systems. And so in a similar nature, you know, I see this as an opportunity to create our own commercial off-the-shelf solutions as an industry to make the non-differentiated heavy lifting easier for Ford and for other OEMs and for other tier ones to complete and execute. So that would be my off-the-cuff response to that question. It was a good question.
Very good. Katrine, you mentioned in your talk about trying to get uniformity and different data sets. So you mentioned cybersecurity, HMI, a number of different things. What do you see when you look at common data sets to realize CVII? How would you prioritize the data sets that you would want to try to get some more commonality out of, and what kind of tangible benefits might that look like in terms of the vehicle design and going forward? Any thoughts on that?
Yeah, I think this is exactly the discussion we need to have between OEMs and also with the different ecosystem players. So when looking at some services that are developed at Renault, we already see that there are common data sets underlying. So whether it's on the fleet asset management or maintenance or even connected insurance, but we also need to discuss with the people who are consuming and also already deploying the services to have a common understanding about the use cases and about the required data. And I think another thing is what is important is to separate complexity between the use cases we want to address, make simple, easy to use interfaces relying on common formats and providing the development environment like SDK, and separating constraints like system constraint, how we secure the data, how we address functional safety constraint, and not mixing these aspects into the same discussion, because then potentially the resulting solution would be too complex to implement. And this would hinder ecosystem rather than making them progress.
And do you see, Katrine, a kind of a prioritization of what those data sets might be as far as safety implementations or things, a certain level of what would come first, second, third, so to speak, in your mind, of where we need to prioritize that commonality of data sets?
Well, I think in ecosystem of mobility, there are common data sets that we need to provide, and fleet management and mobility services would be really, I think, an area to look at. And again, as I said, have discussion between the different players in this ecosystem that are evolving.
Okay. And that's a good segue. Nicholas, you mentioned the need for common data set models for more public good outcomes. Can you share your thoughts on what some of those public good outcomes might look like from your standpoint?
Yeah, sure. At Volvo, just as an example, currently we share some limited data related to safety things, like if one Volvo car detects that the road is slippery, then we can share that with other cars. And that is great, of course, but it's not really excellent, because even as much as I would love it, Volvos are not the majority of the cars on the roads, not even in Gothenburg, or maybe in Gothenburg. So we're not able to share that, the fact that the road was slippery in any sensible way with Ford or Renault or all the other car brands. Or if the same thing, if there's a pothole that you detect, you would like to be able to have some way of sharing that information with all the other vehicles around you, all the other people who will drive down that road seconds, minutes, or hours later. So I think in general, anything to do with safety is something where I see one really important, and to me quite prioritized area. I think another area would be related to energy consumption. To be able to share actually maybe charging level or fuel level and location would make it possible for example, the PG&Es of the world, the power providers to optimize, instead of everyone individually trying to find out where to charge their vehicles, they could optimize the whole fleet of cars that are driving, because they know where people are going and what the different cars' individual charging status is, and they would also know the situation at the charging stations. And that's another example where I expect as electric vehicles become more common, we will need to do something to handle the grid capacity. And that's where I think we need to also find a way of sharing data more intelligently.
That's a great point. And you've all brought up obviously our migration to vehicle electrification and the path toward autonomous transportation. I'm curious, among the three of you and your peers obviously across the industry, as we move toward a different propulsion system for vehicles and autonomy, how would you describe the information sharing among you today, and kind of what you think are going to be the key things going forward as more fleets move to electrified vehicles and we start to implement more autonomous drive systems as well? Where are your thoughts on where we are and where we need to go on that path?
I think we're still in really early days. We find it difficult to find commonalization even within one OEM between different car models. And it's, of course, exponentially worse when it comes to communicating with other OEMs vehicles. We're building currently our own, everyone has their own OEM unique cloud solution where we aggregate data in different ways. And there's very little communication between different OEMs cloud solutions. There are some third parties that try to fill that void, but it's still very difficult for them to do that, because it's always dependent on specific integration with each OEM, if not with within the car, at least just to integrate with whatever cloud we've built. So it's really early days.
Okay.
We haven't really gotten very far.
John or Katrina, any thoughts on that or not?
I do. I was going to give Katrina the opportunity to go first, but I'll jump in. I think it's pretty simple. I don't think you can fight a war on 3 fronts and be effective. And so if we're putting engineering expense into managing complexity on the vehicle side, that's funding that can't go towards some of the forward-looking things that we're seeing disruptors in the industry tackle successfully. So it's you've got limited resources, you've got limited talent space. You know, where are you going to place your bets? And where are you going to transition into commodity ecosystems so that you can make those big bet investments? And I think it's really as simple as that when you cut it to the business level.
Very good. I do have a question coming in from the audience. Do you consider a fair data ownership policy in this new ecosystem, and one that respects any data coming from the vehicle, who has an owner, and how is this personal data protected? Do you have any thoughts on that? I don't know who wants to take that question first. Maybe Katrine?
Yeah, so I think that the data ownership and consent management in terms of privacy, that is already pretty much defined on a GDPR basis. So data sharing for all data that is subject to that regulation anyway has to be managed correctly in terms of consent management and sharing of this data. I think what the Common Vehicle Interface Initiative is about is standardizing that data. So when the user consent is okay to share the data, it can be managed in the most useful way and exchanged between, as Nicholas and John mentioned also several times, between the cars and between different ecosystems. So that's our challenge, essentially. And if data needs to be anonymized to be able to be shared, these are also mechanisms that can be implemented.
Thank you, Katrine. Related, a question coming in is, in your collective opinion, how can we make data standardization a high priority across all OEMs and motivate this to become a universal focus and initiative? What are your thoughts on that? Maybe Nicholas and then John.
I really feel that I don't know how to make it a top priority, because like John was alluding to, we all face other issues and problems that might be even more important to deal with. First of all, we're always under pressure to build whatever the next car is, and there's a lot of pressure in terms of electrification and the shift to autonomous vehicles and so on. And those problems are probably going to stay, how can I say, at the very top of the list of priorities, at least. I don't, if there was like a very easy, like golden nugget way of solving this, then I would tell you for sure, if I knew. But I think it's about starting these kinds of collaborations that we're doing here with Geneva and W3C, getting the discussion going, and then it's very much about culture and culture in terms of how much we dare to open up, and potentially if there might be someone who can help us lead the way a little bit in terms of finding commonality, something common to stand on, kind of like what I feel has happened a little bit with Android in the infotainment domain, where we were trying to build a common software platform. We were able to share specifications, but we didn't really get to the point of one common platform. now we are tagging along on Android as an open source platform. I could imagine something similar potentially. It feels like I'm ranting now. I'm going to shut up for a bit. Sorry.
John, any thoughts there as well from your side?
Yeah, thanks, Chris. Boy, I think Nicholas hit the nail on the head on the business priority on this one. It's obviously we have significant pressures to deliver at volume, high quality products, and that will always take precedent within a traditional OEM. I think two things that are shifting or potentially shifting in the industry is from a generational perspective. If you look at the millennial generation, they're more used to customization through software, not through hardware. And then two is you're seeing a disruptor in the market, not high volume yet, but profitable for over a year now, that has used that moniker of customization through software, not hardware, and made it into a business. And I'm not saying that's holistically their mandate, but it is part of the puzzle in which they operate. And for those that don't know, I'm referring to Tesla. And so if I'm looking at this going forward, I'm saying, well, the opportunity then from an OEM perspective is, how do I, a horizontally operating business, scale to compete with a vertically integrated business that is differentiating their experiences through software and not through hardware? And so from a timing perspective, and to Nicholas's point, I don't have a crystal ball on how to do this in the auto industry. I mean, it's telling that this has not been done in the auto industry to date. But looking at it from a necessity standpoint of saving money, making money profitably, and giving the customers really what they want, hypothetically speaking, if the customer or a future customer of Ford wants a differentiated software product within their transportation module, well, then, I mean, that's what we got to give them, right? And so that the market forces at the end of the day are going to drive that change.
And one last question, I know we're just a moment over time, but wanted to ask this. Are there any other standards or organizations that you feel need to be engaged in this process of CVII and the integration of data? I don't know if any of you have a particular thought on that.
I can take a first stab at it.
Sure.
I think practically speaking, and we'll debate this, I think, much more in the coming weeks, I hope, you're not going to open source everything. You're going to have some industry standards. We've already established those for diagnostics in the vehicle, and you're going to keep some things proprietary. But things like brushless DC motor, back EMF, I mean, that's not proprietary. That's a standard physical interface for actuator. Like no one cares. So you're going to need organizations to create those industrial standards that Geneva and the open source community can sit on top of. So in the industry, AutoZar is an easy one. Canon Automation is a good reference point for interfacing into manufacturing communities. To list a couple, and I think I'll close there and let the other panel members respond.
Thanks, John.
Yeah, so maybe to complement, I think the objective to have something commonly shared and open source, in particular at the API layers and the data formats, that's I would say our common mission as I see it. And then there are underlying industry standard that exists. So if we look even at the smartphone space as an example, even it's running Android, it uses complete industry standard for underlying communication, whether it's the USB standard, the Bluetooth, the 3GPP. And I think this is the sort of split we need to think about when having industrial standards that already exist and how they fit in a complete technology stack when talking about bringing vehicle data. Obviously, we have in-vehicle buses, but also how we bring them outside and where we should concentrate in terms of the standardization of data formats and APIs for a business logic we want to address.
Very good point. Nicholas, any last thoughts on your side?
Yeah, sure. No, I mean, to me, I'm actually mainly, to me, that one driving factor here is to be able to share data between companies and industries and entities, and that is where I see the huge potential, and even in some cases need, like in the case of managing a fully electric fleet of cars, and how you optimize that to fit with your power grid. So to me, it's about data sharing, and I actually think that I was still mulling over the previous question, how you can do this, and I realized that I do think that if we fail doing it, one way it also could happen is through legislation, where larger countries or unions of countries might actually legislate and force us into doing something. That is maybe not the optimal way. The best way is probably if we are able to do something sensible together by free will. But that could be how this plays out as well. Either European Union, it's kind of like what you had with GDPR. You could also force openness around data in a similar way.
Reminds me of the PCI Standards Council in some form.
Yeah.
Well, thank you. We're a little bit past our time, but I do want to thank Katrine, Nicholas, and John. This has been a great discussion. I think we could probably go on much longer. For our members of the audience, if you have questions that we were not able to address, by all means, please feel free to reach out to Katrine, Nicholas, and John offline. This is wrapping up our morning panel session. This afternoon, we welcome you to join us for the CVII workshop that will be via Zoom link and in swap card. And then tomorrow, Wednesday, you will not want to miss our Wednesday session that will be on the Android Automotive SIG, followed by our cybersecurity sessions that will also be available tomorrow afternoon. Thank you all for this segment. We are now going to segue to a break, and we're going to be showing some updates from Itemis and from Geotab. So please come back for the afternoon workshops, and thank you so much for your time this morning. Take care.
Hello together. As you might know, the draft international standard of the ISO and SAE 21434 is available since mid of February. A central part of it formalizes how to perform a threat analysis and risk assessment, or short, TARA. It basically takes the definition of the item that should be analyzed and yields the risk treatments for each threat scenario that was identified. The subsections 8.3 up to 8.9 detail on how to do that. This analysis is actually performed various times throughout the whole life cycle, from conception up to the maintenance later on. After I told you all this, you might be wondering how to practically run a TARA that conforms to the ISO 21434. My name is Bastian Kruk, and I work for Itemis. And in Itemis, we are building the Yakindo Security Analyst. That is a tool that is supporting you in doing exactly that, a 21434 conformant analysis. In this example, we will analyze the risk of spoofing a message on the CAN bus in a car. In this case, it will result in the headlamp turning off unexpectedly, which can be a dangerous thing if that happens at night. We will try to enter the system through the navigation ECU, which has both access to a cellular network and also a Bluetooth feature. We will try to compromise them both and consider which one is the more feasible attack. So that much about the item definition. Let's go on with identifying some of the assets. To identify the assets, we walk over each system element one by one and decide if it demands confidentiality, integrity, or availability. So that is the question, is this an actual relevant asset? For example, regarding the lamp off request, the confidentiality might not be something that we want to consider. So let's reject it. And regarding the integrity, it was already accepted, so there was a security objective created behind. And we can decide for a damage scenario. So that might be something like blowing up. Well, we can create a new damage scenario in here and reference it, but in this case, let's go for some existing one, which is the headlamp turning off unexpectedly. That is what would happen if the integrity of this function would be violated, right? So now that we identified our asset, let's skip over the threat scenarios for now and go on with rating the impact of it. Here we can see the damage scenario, headlamp turns off unexpectedly. It has a severe impact level, which is the combination of the various factors we assessed for it. It is severe because taking the maximum of it, well, we decided it to have a life-threatening impact. That is a severe thing. Opposed to this, the headlamp turning on unexpectedly is not as bad, it's just serious, because it is a serious limitation in vehicle operation. Now that we discussed the impact of the damage scenarios, let's go back to the security objective, which we created during the asset identification. Remember, the integrity of the switched off request is the one thing that we are considering, and we just rated the impact of this damage scenario to be severe. Let's have a look at how we get to this medium attack feasibility level. So on one hand, we need to send a CAN message from the compromised navigation system. But in order to do that, we need to have access to the navigation system, either via a cellular interface or via Bluetooth. We can also look at the whole attack tree in this graph and see that the resulting risk level seems to come from, on one hand, the attack feasibility that is needed for the CAN message, and in this case, the Bluetooth attack was the easier one, right? So the attack feasibility from this one is highlighted. Since we now had a look at the attack path, let's come to the attack feasibility to see how the security analyst comes to mind about this. For that, I open the attack step 3, which was the compromise of the navigation system via Bluetooth. As we can see here, both of them have the severe impact level, which is calculated based on the damage scenario that comes from the integrity security objective, but they have different attack feasibilities. For a cellular interface, it is low, and for the Bluetooth interface, it is medium. For attack steps, the feasibility is determined via factors. So, as suggested by the ISO 21434, we are using a couple of factors that are rated and have a degree of feasibility from very, very low to very high. These values are converted into numbers and summed up so that we in the end come to a medium attack feasibility here, and the risk level that results from this is also a different one in these cases. That's why what we can see at the bottom here. Now that we have had a look at the attack feasibility, we can finally determine our risk. We already saw the preview here that it's going to be about a risk of 4, because let's assume the attacker takes the easiest path. And in the result report, we will be able to see a risk distribution diagram that determines our risk with a medium feasibility and a severe impact over here. This is actually a view where we can customize the elements that will come up in the final exported PDF or docx or even HTML report. This is the one that you can hand over to downstream development or to auditors of the security plan. So after we've been speaking about all this, and I've been showing you all that, you might have further questions, such as how we are treating risks or how we are dealing with controls, because controls sometimes also introduce an asset, such as the confidentiality of a security key, right? The private key needs to be confidential, and it needs to be considered. We support all this, but I didn't want to give it all away. Most importantly, you learned that a Terra can be structured and documented in a way that allows refining it later on without ending up in a mess of interdependent spreadsheets or having to reperform the whole analysis. If you have questions or want to know more how we allow such incremental and iterative workflow, contact us at security-analyst@itemis.de, and we will be happy to set up a personal call with you to tell you more. That's it from my side, and I will now open my inbox and check if I got a mail from you. Speak to you soon.
You cannot manage what you don't measure. People's time is the most expensive and valuable asset in a company. And this is the secret way that Geotab goes to market. We work very closely with the customers. We understand.
We started thinking about what do we do really well. Over the 20 years of growth, we've helped you all stay agile, productivity, fleet safety, compliance, expandability.
Every 1 in 5 trucks that you see on the road today in North America has a Geotab device installed. It's amazing.
This is a very vibrant, very healthy ecosystem.
We need to think about what is the future of connected transportation.
It's the year 2020, and it's time to launch a 6th pillar, the sustainability pillar.
We have to open our customers' minds to the art of the possible. This is the future.
We essentially take in the 2 billion raw data points a day that are from our collective vehicles, almost 1 million vehicles at this point in time, driving around the world, and we figure out what to do with that. We have an infrastructure team that processes all of this data in near real time. We have a data solutions team that figures out all sorts of really cool use cases. Some really cool stuff that you wouldn't get to otherwise do in some of the other departments. So you can actually look at all of the trips that we make as an entire organization from our 1 million vehicles, and we've got 16 trips to the sun included in all of that. Who would have thought of using vehicles as virtual weather sensors? One of the challenges that we have is in benchmarking our customers, understanding, looking at all of this data, thinking outside of the box about what features we can use from the data coming in to tell us a little bit more about this vehicle. You really get to think creatively and out of the box with a position in this department. I think every single person in my team has a passion for data, wants to learn more about it, investigate it, get to the do root cause analysis, and really think about those derivative insights and use cases that come from that data. You, in this role, almost in specific, you really have to ask the right questions of the right departments and learn as much as you can when it comes to the realm of machine learning, data science. Start developing those skills from a data acumen perspective, but you're able, through asking the right questions, learn very quickly and leverage the resources we have in here as well too. The future looks really, really bright for Geotab.